Hi everyone. So we are continuing in Module 1. We're in Topic 1. We are in Lesson 2, and this will be our first session of this. It'll take us at least 2 videos or 2 days even in class to get through this. It'll probably be more videos than just 2. But searching for common ground. So we're going to be identifying common factors and common multiples. Our learning goals: to use powers and exponents to rate the prime factorization of a number. Determine the greatest common factor of 2 whole numbers less than or equal to 100. Rewrite the sum of 2 whole numbers with a common factor as a product using the distributive property. So that's back to our first lesson. Determine the least common multiple of 2 whole numbers less than or equal to 12. Key terms: common factor, power, base, exponent, greatest common factor, we also call the GCF, relatively prime, multiple, commutative property of multiplication, and least common multiple, we also call the LCM. Okay, so let's get started. In the array of numbers shown, circle the prime numbers, cross out the composite numbers, and use a box to identify any number that is neither prime nor composite. Okay, so, and we went through the list of papers. We had that colored chart that you had on factors, where all of the different factor pairs were in different colors. If you need to pull that out to look at your prime and composite, remember you went through and you put a P on all of them that were prime. So remember, a prime number, it only has one as and itself as factors. So, and we are going to circle prime. So 2 was prime, 3 is prime, 5, 7, 11, 13, 17, and 19. We know all of the even numbers other than 2 are not prime, they are composite. So what about 9? Well, we can do 3 times 3, so that is not prime. 15, we can do 3 times 5, so that is not prime. And the number 1, it's neither prime nor composite. One can argue that its only factors are 1 and itself, but there really isn't any other additional number other than 1. So they're saying it's not prime or composite. Okay. That's a time sign. I was supposed to say 1 times 1. Okay. So moving on. How many rectangles can you build? Understanding the area of rectangles is helpful when learning about factors. A rectangular area model is one way to represent multiplication. You and your partner will create area models for the numbers 12 and 16. So in class, we're going to do this. If you're watching this video at home, then you're not able to do this exactly as we will in class. So one person's going to be assigned the number 12, one we assign the number 16. So you can kind of follow along as I am on this video. Ask yourself, how do you know whether you have created all the possible rectangles with a given area? Use a grid paper located on page 23 to create and cut out as many unique rectangles as possible with the area of your assigned number. So we're going to cut them out first, then we'll label each rectangle with its dimensions, and then list the dimensions of all the rectangles that you created for your assigned number. So let me find page 23 here. So page 23 looks like this. Okay, so this grid paper. So if we were going to create a rectangle, let's start with a larger number, 16, for example. How might we do 16 with a rectangle? Well, I could do it just one across, and then it would be 16 long. How else could I do it? I could do 2 across and 8. And let me show you, I already did that on another page. I'm going to show you that. I'm going to kind of cover up the 12 here. Okay. So for the 16, I did 1 by 16, 2 by 8, and 4 by 4. So if you're at home, pause the video and do that right now. Just kind of sketch them out first and label them. And then we need to do that for the 12. So to get the 12 to fit on, I did the 1 by 12 over here on the side. And then I figured a 2 times 6, a 2 by 6 would work. So I put that right next to it there. And then a 4 across by 3. Okay, so once you have those all drawn, then go ahead and pause the video and cut them out. I'm going to do the same thing. Be back momentarily. Okay, so I've cut out all of my rectangles. So let me sort them here. Up here are the ones that are the area of 16. And then here we have the ones that are the area of 12, kind of in the bottom half. Let me try to get these all in the frame here. Okay. And let's do that. Okay, but then number 1 says, label each rectangle with its dimensions. Did that. List the dimensions of all the rectangles that you created with your assigned number. So for the number 12, the dimensions were, I'm going to put like a colon here after it. So this is for 12. I have a 1 by 12. I have a 2 by 6 and a 4 by 3. For 16, we had a 1 by 16, a 2 by 8, and a 4 by 4. Okay, so next it says, how are your factors represented in your rectangles? So in these rectangles, how are the factors represented? So remember, these are the factors. So how's the factor represented? Where do you see the 2? Well, the 2 is this distance here, and the 8 is here. On this 1 by 16, the 1 is represented here, and the other one here. So the 1 number is always the length, and 1 is the width. So that's how we're going to say that. We're going to say each side length represents a factor and the dimensions of each rectangle. So one factor is the length, the other factor, so the other is the width. List all the factors of 12 and 16. So if we have 12, the factors of 12 are 1, 12, 2, 6, 4, and 3. They're each of the factors. So we'll list those in order, though, from smallest to biggest. So we have 1 times 12, 2 times 6, and then 3 times 4. And for 16, we have 1 and 16, 2 and 8, and then 4 and 4. So we only have to list the 4 once. Okay, pause if you need to. I'm going to continue on. Together with your partner, combine one of your rectangles and one of your partner's rectangles to make a larger rectangle. Use this method to create additional rectangles. Complete the table with the information for each larger rectangle that you and your partner created. Okay, so these are our smaller rectangles, and we're supposed to put these together to make one bigger rectangle. Okay, so which ones could we pair up and how? Like, that doesn't make a rectangle. Okay, it's a compound shape. There's two different shapes put together. But what could I put like with this 4 by 4 to make another rectangle? Well, I see a 4 here, so could I line my 4 sides up? Yeah, so now I have a bigger rectangle. And with the 2 by 8 and the 2 by 6, I could get a bigger rectangle like that. And then I don't know if I can actually even get this one in the camera view. Yeah, I did. We have a 1 by 12 and a 1 by 16. So go ahead and do that with your rectangles. Pause the video, okay, and then come back. I'm going to move on. So it's asking us to list the dimensions of the smaller rectangle. So let's do this long one first. So the smaller one, so we have rectangle number 1 and rectangle number 2. So here we'll do all the ones that had an area of 12 right here, and these we'll do the ones that had an area of 16. So we had a 1 by 12, and here we had a 1 by 16. So we had length times width. Notice it has a small little 1 there and a small little 2 here. You read that width sub 1 and width sub 2. So that means like width number 1 and width number 2. But that's how they put it, so that they're telling us it's two different shapes. And then we're supposed to write it as a larger rectangle. So what are the dimensions of our larger rectangle? Well, it's a 1 by what? They're 1 by, so we have 12 plus 16. So we're going to write it's a 1 by 12 plus 16. So the area of the smaller one, area of the first one, this is area of 1. This is the area of the second one. It was a 1 by 12, so that area, length times width, is 12. The area of this bigger one was 16. And that's what's happening when we distribute this here. 1 times 12 is 12. 1 times 16 is 16. So when we add those together, we get 28. Okay, so let's look at our two rectangles. So our smaller one was a 2 by 6. So 2 by 6. And our other one, our A1, our A sub 1, our area of our smaller one, area of the second smaller one, A sub 2, is a 2 by 8. When we combine them together, it's 2 by, here's 6 and 8 more, so that would make 14. So it's a 2 by 6 plus 8. Okay, so what is the area of our first rectangle? Our A sub 1. So this one is like the A sub 1. So this would be 2 times 6, 12. And the area of this rectangle is 2 by 8, 16. And again, when we add those together, we still get 28. And finally, our last one, we had a 4 by 4 and a 4 by 3. So 4 by 3 a 4 by 4. Our side that we had in common was the 4, so that's what's going out in front. And then we had this one was 3 plus 4, right? Because this one, it's 4 across and then 3 this way, plus 4 continuing in that way, 3 and 4. So what is the area of this smaller one? 4 by 3, or 4 distributed here to this 3. 4 times 3 is 12. What's the area of this one? 4 times 4 is 16. So the area of the entire great big rectangle now is 28. Additionally, if you would just count these squares, you would get 28 squares in there. Number 5 says, how are the dimensions of the larger rectangle related to its total area? Okay, so how are the dimensions of, like, let's look at this one, of this bigger one related to its total area? So the area is length times width. So then the length, let's say we're just doing L for length. I could write it out. If you want to put an L, you can. The length is the dimension that the two rectangles have in common. Okay, so they have them in common. The width is how do we get the width? So then we added them together, is the sum of both. The length is the dimension the two have in common. The width is the sum of both lengths of the smaller rectangles. Okay, number 6. For each larger rectangle you and your partner created, write a numeric expression that relates the dimension of the larger rectangle to the sum of the areas of the smaller rectangles. We literally already did that here, right here. Okay, so the first one we had 1, and it was a 12 by 16. When we distribute that out, we're kind of showing it here going backwards. It was 1 times 12 plus the 1 times 16. For the one that had a common side of 2, we had 2 and 6, and one that was 2 by 8. So we had a 2 by 6 plus a 2 by 8. And then for the 4, we had a 4 and then a 3. Sorry, this should be plus in these. Plus, oh, sorry. Plus, plus, plus 4. So we have a 4 by 3 and plus a 4 by 4. Number 7 says, consider any factors between your number and your partner's number. How are the common factors represented in the larger rectangles that you and your partner created? So the common factors, hi Jessie, this is my kitty Jessie. I don't know if you can hear her meowing. She wants my attention. The common factors are the side lengths. Right? We lined them up. So the 4s, we lined up the 4 side. So they are the sides, let's say that line up from one smaller rectangle to the other. Again, you can pause to get this written. How are the common factors represented in the numeric expressions that you and your partner wrote? Well, the common factors were the ones that were out here in front. So the common factors, I'm going to put CF for common factor. You can do that too. Is the number outside the parentheses when I distribute. Number 9 says list the common factors. Well, the common factors that they had in common was the parts that we lined up. So we had a 1, here we had a 4, and the other one was a 2. So 1, 2, and 4. And we are going to stop right there.